Everyone, and welcome back. So this time we're doing a golf problem. Not the most interesting sport in my opinion, but that's just my opinion. I know some people love it. But we can do some very fun projectile motion problems with golf. So, if we know the golf ball is struck with a velocity of 80 feet per second as shown, and we know that it has an initial angle of 45 degrees, and that the ground here is at a 10-degree angle with the horizontal. Well, what's the distance d to where it lands? And you're like, wow, can we really solve that with just this information? And yes, we can. It's not the easiest thing, there'll be some more algebra, but we can figure this out. So what is your plan? Because I send you off and to deal with this on your own. Well, you're going to establish a fixed xy coordinate system, as always. In this case, probably put it a day, and then apply kinematic relations in the x and y directions. Like, that's what you say every single time, and it's so true. It's what I say every single time, and it works every single time. So all you have to be really careful about is your algebra. So, pause. Go work on this. Come back in a few minutes and tell me how it went. You might look a bit strange because you're just talking to your computer, but act like you're Skyping if you do, because this is a video and I can't actually hear you. But that being said, I'll give you 3, 2, 1, okay. Hopefully you paused and you got what I was doing and you went into the problem. If not, pause now and go to the problem and come back. So let's try it out together. So first off, as we do in the last few times, let's write our equation for the x position first. Now, if we're trying to figure out how far it is actually going, what the angle is, well, the first thing we're going to have to realize is that 45 degrees right there, yes, it's true, it's 45 degrees from the ground, but that's not from the horizontal direction. So that's why we have cosine 55 here. So our V naught, VA, if we're trying to break it up, well, this is 55 degrees because it's 45 plus 10. And so our V naught in the x direction is going to be our initial velocity, which is 80 cosine of 55. Now, we don't know what d is, we don't know what the time is, but we have a nice little equation here that relates the two. We can say that the time is equal to 0.02146 times d. So hopefully, in a future problem, our future equation, we'll be able to plug this in and solve. Okay, now how about the y distance? Well, we know that after traveling a distance d in the somewhat vertical direction, and mostly horizontal, but somewhat vertical direction, it lands at b, which means that we can likely get this in terms of d. Okay, so we knew that yb is going to be d sine of 10 degrees. That's just 10 degrees, and we're breaking this up right here. 10 degrees, and there's a vertical one. We know its initial position will be 0. We always make that 0. You can make it whatever you want, because this will just be a difference. But it makes more sense for it to be 0. Then we put in our v naught y, which is going to be sine of 55 degrees, because we're taking the opposite over the hypotenuse right here. And we multiplied that, but what we've already solved for the time. Plugging that in here, and plugging it in here. The last thing to be very, very careful about is this is feet per second. Feet per second, which means gravity is 32.2. That is the biggest and most frustrating error. Oh goodness, I had a student last year had one problem, and the only mistake he made was that he had the wrong gravity. I stared at that problem for a solid hour because he had done every step correct except for gravity, and just like him, I didn't see it. Until finally I looked at his units and it hit me that he had the wrong gravity there. So be very, very careful. This is one reason that you should always show your units, because that will be a very frustrating mistake, and I can guarantee that one of you is going to make it. Okay, so we plug it in. We solve. Only one of the values of d will make sense. One is 0, and yes, that doesn't really make any sense. And only the non-zero answer is going to be meaningful. So 166 feet, which, okay, let's be honest here. Like, if I'm looking at this visually, if this was not drawn to scale, that does not look like 166 feet. Or this guy right here is a giant. If we're looking at this, that's like, this man is 80 feet tall. He is huge. Okay. So with that, we are able to solve how far the ball went. So that ends this section. Thank you for listening. Thanks for doing the example problems with me. I know projectile motion can seem really scary, but once you see how you simplify the equations, once you see how to set them up, it really will go fairly easily. But if you're struggling, just come to class. You have to anyway, there's going to be quizzes. And we'll work out problems together. We will go through it together and figure out what's going on, and we'll help you get through it, okay? So have an absolutely wonderful day. I'll see you later. Bye-bye.